Okay. Look, you're all doing it wrong, and you want to do it right, so let's see if we can make it easy, right? My name is Rob Napier. We're going to talk about security today. This is going to be highly technical, and it's going to be very, very fast, because I don't have a lot of time. I got to figure out which button it is. Awesome. So today, we're going to talk about encrypting your network traffic. We're going to talk about data protection. We're going to talk about protecting secrets and what's the difference between secrets and data.
Yes.
We're going to talk about handling passwords. And my personal favorite, we're going to talk about how to encrypt things correctly, because you're probably doing it wrong, because everybody does. Sorry. Everything is at this URL at the bottom. That's the only one you need. I promise all the code's there, all the links are there, everything. Even the slides, everything. Okay, let's jump into it. Number one thing, if you get nothing else from this whole conversation, get one thing. Turn on HTTPS. You get all of this for free. You get this for free if you do it wrong. It is one of the few security things you can do that even if you totally screw it up, it is better than not doing it. Look that up for me, thanks. So please, turn on HTTPS. There we go. That is a great best practice. But here's the thing. How are you going to do it? What are you going to do with certs? This is always everybody's problem. Most people go, come on. Most people go with a commercial cert. They're fine. Like them, they're, whatever. You get them from VeriSign or whatever. But I'll tell you what. VeriSign cert is not the best cert. It's not the most secure cert. The best cert is self-signed. Oh no! Self-signed certs, worst thing ever, right? No. When you get that VeriSign cert, it is signed by all of these guys. It actually, when you say I will trust a cert that's in the keychain, there are 211 different certs you just trusted. They include people like Cisco. I actually helped get that one in the keychain. Why are you trusting Cisco? Why are you trusting Chimera Firma? I don't even know who that is. You trust all of those guys the moment that you say, I will take trusted certs. When you pay VeriSign your $50 or $400 or whatever you're paying them, you're not paying for security. You're paying that browsers don't pop up a little thing that says, hey, this is untrusted. That's all you're paying for. But you're not running in a browser. You're writing apps, and you're talking to your server. You want to trust one cert. That cert is your cert. That, by the way, that little link at the bottom tells you is the full list of all the certs that iOS trusts. If you trust you have to keep your cert secret. You have to keep your private key secret. And you have to trust that VeriSign keeps their private key secret. You may trust them a lot. It's still more trust than if you just trust you, because you still have to protect your cert. Don't argue with the math. OK, so how do you do it? We're going to tell you what. First off, I'm going to stop saying self-signed cert, because you know what one of the biggest self-signed certs in the world is? The VeriSign root certificate is a self-signed cert. That's what it means to be a root cert. So let's change it. We're going to call it something that's a bit more meaningful, and that is certificate pinning. I just learned this term like this year. It was within the last year. But it is a great term because it's really what you mean. It is you want to pin your trust to one cert, the one you made. Now, it doesn't mean we take any random certs, just the one that you want. And let's see how we would do that with NS-URL connection. It's actually a bit of a pain in the butt. That's why I wrapped the whole thing up. And now you need like one line of code. All you do, you open up, you take that certificate, that public key, stick it in your bundle. Include one header file that I give you. And in this crazy delegate callback method for NS-URL connection, make one call to validator. And that will either cancel the connection or proceed, depending on whether you're matching that one cert that you put in your bundle. And that's all it takes. You're done. So Encrypt your traffic, use HTTPS, pin your certs. I gave you the code. Moving on. Data protection. This is one of those things, we can have big arguments as to whether data protection on iOS, and by this I mean the low-level encryption technology that Apple gives us, is worth it. I'm here to tell you it's worth it because it's really easy to turn on, and your customers are therefore going to rightfully expect it. So what is it? Here is a really simplified version of how Apple does it. And this is what's called file encryption or data protection. You've got some document, and you put a flag on it that says, come on, there you go. You put this flag on it that says, I would like protection. The system is going to make a key based upon the user's PIN. So this is based on how strong that PIN is, or long password on an iPad. The file is immediately encrypted the moment you ask for it. You can still read it, though, because that key is still held in memory. Then as soon as the user hits the lock button, within 10 seconds, the key goes away. They just shred the key. Then when they unlock it, type in their PIN, it figures out the key again and decrypts it. And you can start reading your file again. So as I said, as soon as they lock the device, within about 10 seconds, you can't read your file anymore. Well, what if you need to read your files like when they're in the background? There are some options you have here. The best option for protection is called complete. That's what I just described. The next is complete, except for the files that I had open when you were locked. So if I had this file open, my log file, the file I'm downloading, the file I'm uploading, my database, if it was open at the time that the device was locked, please don't encrypt it. Leave it available. That's a pretty good level for a lot of your files if you can't do complete. It's also the only level you can use if you create a file while you're in the background. And then there's this other one for these really crazy cases. It's called complete until first user authentication. It literally means from the point that you boot the device to the first time the person enters their PIN, it's encrypted. And then it is not encrypted until they reboot the device. It's better than nothing. It protects against some very difficult, certain kinds of attacks. But try to use the other ones. The main reason, though, that I say use this, even with all this, is it is so easy now. How easy is it? You go to your profile, your app cert profile, and you say, turn it on. Please, turn it on. I think, now I haven't double checked, I think you can even do this in Xcode now. I have to double check, but you can definitely do on the app certificate. And you just go, and I click complete protection, download it, install it. We're done here. OK. How about, though, if you need a little more control? And sometimes you do. You can do it in code. The most obvious way is with NSData. There's this NSData writing file protection complete. And you can assign these right when you create the file. The other way that you can do it is with NS File Manager, you can assign it to existing files. And this is really useful. Say you create a file and you need to set it to until open or while open, and then later you can upgrade it to complete. You can even do this while the file is open. It doesn't care. So that's really useful. You can also, there's all this stuff. I mean, you can find out when things are going to become available or not available and all that. Most of this stuff you don't need most of the time. Because really, you just say complete, or maybe complete until open, or until while open, and you're kind of done. So just do it. If you want all the gory details, I really glossed over how Apple does it. This document, again, the links on the site I gave you at the beginning, is their gory details on their elliptic cryptography and whatever, elliptic curve cryptography, and all the multiple subkeys, and if you want it, there it is. So that's data protection. Turn it on. Use complete if you can get away with it. And then for others, use complete less open. And if possible, get back up to complete when you can. That's data protection. Secrets. What's a secret? A secret in the crypto world means a little piece of data that is used to get access to a bigger piece of data. So a little piece of data is usually a password or a key. So your document is not a secret, even though you might think it's my secret document. No, that's called ciphertext. The secret is the password you typed in. So what are you going to do with them when you have to hold on to them? The place you're going to put them, frankly, is in keychain. Why do you use keychain? Well, frankly, it's what Apple gives us. And it does have some nice things about it. It automatically handles encryption for you. It automatically handles backups and iCloud syncing. And it actually does a pretty good job of all that. It is incredibly persistent. Keychain data is the most persistent stuff in the world. You can be uninstalled, reinstalled, and you still get to, your data is still there. I'm not recommending you put non-secrets in the keychain, like configuration data that you'd like to keep around for a while because it never goes away, but you know, you could. And it's also useful for sharing data across applications. This is because we'll talk about it in a second, but you can share a little bit of data between your apps. It's mostly used for sharing credentials. You have a bunch of apps, and you want to be able to have them all log in without the user having to type in their username and password over and over again. This is how you do it. And we'll talk about that. So, but here's the thing. Keychain stinks. It is a pain. The API to it is insane. Very, very complicated, and it is the slowest thing you will ever call. So what do? Use a wrapper. I don't love any of the wrappers out there. I'll probably write my own soon. But this is my favorite one currently. It's called SG Keychain. I like it for a couple of reasons. One is it treats the whole credential, the username and the host and the password, as one atomic thing. Some of the wrappers don't do that. They let you set the password and set the account separately, and that creates a mess. And supports access groups directly. And we're going to talk a lot about access groups here in a second. So the first thing you need to know is iOS has one keychain. Your app does not have a keychain. There's just the one. They give you the illusion that you have multiple keychains because you are in an access group. And an access group is just a tag attached to a keychain item. So my app A can go to group A, and my app B can go to group B. And when app A tries to read from group, come on, do it. From group B, it just gets, I'm not allowed to do that. That's all there is to it. So what's this? And literally, it's just a big database, and one of the columns is access group for the items. So what is an access group? Well, it's just a string. And the string starts with your app ID. And then it has, I say reverse DNS, an identifier. That's traditional. You can put anything you want. What has to be there is your app ID followed by a dot. That's how you have access. So, I mean, it would kind of look something like that. And we call that an access group. How do you set this guy up? Entitlements. So you go in, and now you can do this all in Xcode, or directly in Xcode. It's really nice. So, I mean, you just create an access group and say, I want this keychain group. And the thing to note there is it actually, remember I said the access group starts with your app ID. You don't see it here. It's an annoying thing about the interface. It is put into the entitlements file. You'll see it there, app identifier prefix. And the prefix is, in fact, your app ID followed by a period. There you go. So you create that thing, and you put in. But this is where it gets just a little bit tricky. Say you have a bunch of apps. Remember, as long as they have the same app ID, they're signed by the same certificate, they can share all the groups. And as long as they all list exactly the same access groups in that entitlements in the same order, it'll all just kind of magically work. You'll never notice a problem. But here's where it is a little weird. When you just come up and say, I would like a keychain item, it comes back and says, it will give you the one that is in the first group you have access to. When you write, it may not be into the same group. So you can wind up reading from one place and writing to another. And it's totally legal to have the same record in multiple access groups. In fact, it's really common. And you wind up with these duplicate records that will drive you crazy. So what I say is always, if you are going to use access groups at all, make sure that they are totally explicit. You pick one and you stick it in there. So and typically I just wind up always having one. It's just easier that way to do it from the beginning. That way, if I ever decide to upgrade and attach them later, I've already kind of set the stage. How do you do it? well, OK, this is SG keychain code. And I need my access group. And I put all that there. But remember I said the access group starts with your app ID. There is no runtime access to your app ID. I have no idea why, but there isn't. You can't actually get it, as best I know, at runtime. Now, you could make a little constant somewhere, but I hate that. It's really fragile. So there's a trick. And again, this code's on the site. You'll have to scribble it down. But the trick is you just create a random keychain item, anything you want. Stick it in the keychain, then ask for it. When you get it back, it'll have an access group on it. You ask the access group, what's the app ID at the beginning? Well, that's your app ID. So if you ever needed your app ID, you can use this to find it out. It's crazy. I don't know why you can't do this more naturally. But anyway, there you go. You create some app, you get your app ID, and now you can stick stuff in keychain. That's pretty much keychain. Use a wrapper. Don't try to use it directly. It will drive you crazy. And use explicit groups. That brings us into these passwords. Well, OK, I've got a password. I'm sticking it in keychain. But how do I really handle that password correctly and well? There have been a lot of password leaks recently in the last couple of years. I mean, I used to have big slides with LinkedIn and everything else on here. But it has been a real problem recently. And no matter how trivial your site is, you've got this cat lover site, and it's like, who cares if people steal these accounts? The problem is people reuse their username and password everywhere. And if when they steal your password database, they turn around and break into the bank, nobody's going to care when you say, oh, well, they shouldn't reuse their passwords. It is your problem. You must do something about it. We're going to learn how. What do you do? Well, the first step is you always hash. And you should never hand a real raw password to your server. Never let it leave your device. Always hash it. So we're going to hash it with a cryptographic hash. Now, a cryptographic hash is a little special. It's not the same as a standard hash. This is not the same as NS-string hash. A cryptographic hash has a couple of things. They have, first, they are what's called collision resistant, which means that it is very hard for an attacker to find two documents that have the same hash. I don't know if you know anything about like the NS hash or the NS string hash. It is trivial to find collisions in the NS string hash. In fact, you will find them by accident when you think it's unique, as I have. The other thing, cryptographers love to use weird words like pre-image resistant. What that really means is you can't run it backwards. That given a hash, finding a document that gives that hash is impractical. And by impractical, I mean impossible. If you think about it, both of these are a big deal because there are, in fact, an infinite number of documents that will collide. Think about it. There are an infinite number of documents. There are a finite number of hashes of a given length. Therefore, every single hash has an infinite number of documents that match to it. And I'm saying, even though there are an infinite number of them, you'll never find a single one. Pretty strong claim. But that is, in fact, the goal of cryptographic hashes. So choose your hash. Really, there's two choices you have these days. The first one is SHA-2, and that is, frankly, what you should use for any new code. This is sometimes called SHA-256. It's a bunch of numbers, but any number that's 3 digits long is, in fact, SHA-2. And it's very nice. It has no known attacks. It's a great hash. SHA-1, despite what you have heard, is not cracked. SHA-1 has had in some cases, has been found to have some minor possible flaws that could be exploited in the future. For cryptographers, that means we now panic. SHA-1 is fine for most purposes. You should not go run out and immediately upgrade all your software if you're using it. However, if you have new software, please move to SHA-2. But still, SHA-1 is fine, and it's even more, it's available everywhere. Then there's SHA-3. There is no reason to be going to SHA-3 right now. It was just selected last year. Remember, in the cryptography world, we've got things that are 11 years old, and cryptographers are still a little nervous about it because it's kind of new. It's a slow-moving industry. SHA-3, eventually we will go to SHA-3, but only when they start finding cracks in SHA-2, and there are no cracks known. So don't even worry about it. You can't run it on iOS anyway. I mean, you'd have to get your own code. Very few people support it. It can be faster. on 64-bit hardware, if you really, really need a fast hash because like you're running servers, SHA-3 might be worth it just because on certain hardware it can, in fact, be faster than SHA-2. OK. But cryptographic hashes aren't actually enough. I mean, linked 1, where we had that massive leak, all that was leaked were SHA-1s. And I said SHA-1 is fine. So they hashed. They used a cryptographic hash. They used a good one. But they still have massive password leak. How'd that happen? Well, if I'm given this hash, it is impossible for me to find a document that matches this hash. And by document, I mean password. But I mean, it doesn't matter how long it is. So I'm never going to find that. But you know, I can guess passwords, and I can hash them. And I can do this all day long. I can have lots and lots and lots and lots of this, and I put this in. It's called a rainbow table. And then I go, hey, I've seen that hash before. So this is totally possible because you hashed, or LinkedIn in this case, hashed exactly the same string I did. So what I want to do is make that really hard. And the first thing I do for that is I do something called salting. And salting says, OK, 2 different sites I have the same password in both of them. And both of them want to do a SHA against them. And they come to the same value. But you know, we could both just stick some stuff at the front. And now they're totally different. And that's all a salt is. It just means I stick some stuff at the front or at the back or anywhere. I just make it a little bit different. And boom, now we're all unique. The best salts are either 6 to 8 or 16 bytes of totally random data. And I'll show you how you would use that. You know, my client would come in and say, I want to log in with this username. I can't give a password yet because I don't know what the salt is. The server says, OK, here was the salt that we used when we created the account. We made up a salt for each individual one. You have to keep it somewhere in a separate column. And then the client can come back and say, OK, great. I'm going to do all my computations. And here's the actual, based on that salt, here is the real hash I'd like to send you. And then the server would send back some session key that says, cool, you're good. And by the way, rather than do this handshake constantly, here's a key you can use to contact me anytime for the next month. And after a month, we'll renegotiate, or a year, or whatever you want it to be. It's good. That is a very good model. And I do recommend it. But I know it causes a lot of people headaches because it's this whole back and forth handshake. And they're like, could I just send one thing and be done? And yes, you can. There is another way. It's called deterministic salts, which means that the client can calculate it before he connects to the server. So remember, the point of a salt is that it be unique to the user so that if multiple users in your database have the same password, they get different hashes, and unique to the between your server and somebody else's server. So what do? You just come up with some prefix for your server. Reverse DNS is a favorite. And then you stick the username or some unique identifier that hopefully won't change for the user on it, that the user knows. And now you stick that. That's your salt. Not quite as good as a random one, but it's actually it's perfectly fine. And this is quite secure. But the main thing you want to make sure is whatever you pick here, it just should be unlikely to repeat. It does not have to be absolutely positively unique, but you should avoid repeating very often. OK. We get into, so even if I have salted hashes, the problem is if a guy has stolen your database and he's trying to find passwords, the entire universe of passwords people pick from is tiny, infinitesimal in cryptographic terms. He can guess all of them. And even with the salts, he can just, especially if he's just trying to crack one specific account, it is feasible. So what I need to do is I need to make guessing expensive. How do we do that? Say I was able to do that. Say I could make it really expensive to guess. And by really expensive, I mean 80 milliseconds. You're never going to notice 80 milliseconds. But I guarantee you a password cracker will be destroyed by 80 milliseconds. Because he needs to make billions of guesses. Yeah, 2 months versus 15 million years. That's what 80 milliseconds can buy you. So how do we get 80 milliseconds? Or whatever, 100 milliseconds, something. What can you afford to get? We use a thing called PBKDF2. The standard is password-based key derivation function. That is a generic term. There are, in fact, several of them. The most famous is called PBKDF2. It is the only one that's available in iOS directly. There are other ones, AESCrypt, bcrypt. They're great. They're actually better. They're not that much better. And PBKDF2 is fine, and it's available, so use it. It is a little bit funky to call. I've wrapped it up in a thing called Encryptor, and I'll be talking a lot about it in a second. But that's all you need to do. You hand your thing in, and you say, hey, give me a key for this password. Encryptor has implementations in a ton of stuff. We'll talk about it in a second, so you can do this on your server, too. And it's going to run it. OK. Really? Crap. Well, we'll do it fast, then. OK. If we do a well, I'm going to skip over that because I need to get into AES. I'll say them quickly. Before you store it into your database, hash it one more time. And the reason is because you want to make it so if somebody does steal your database, they can't just show up with the hash. You want them to say you have to show up with the password that generated this hash. Or I'm sorry, the key that generated this hash. Do it one more time. OK. I'm going to skip consistent time checks because they don't matter most of the time. Let's talk about AES. This is my favorite topic. This is the answer. You will do AES wrong. Don't do it yourself. I've done it wrong enough times for all of us. Please just use the library. OK, some of you are going to go, but I don't trust that. OK, I'm going to tell you why. First, I'm going to tell you how easy it is. Then I'm going to tell you why. That's encryption and decryption. It's that easy. So there are no easier solutions out there. There's also stuff to do NS-URL connections and streaming and all kinds of stuff. That's a lot if you need to do async. It's implemented in a ton of languages. So it's compatible. And I'm adding some more this year. I want to do Scala and some others, probably Haskell. What does it mean to be correct? I'm going to have to fly through this because I'm probably late. AES can only do one thing. AES encrypts 16 bytes of data, period. It can do nothing else. And it needs a password that is a random key. You can't use passwords. Fix like random key, encrypts 16 bytes. That's it. That's all AES can do. You say, but I'm doing other things. You're not using AES. You're using AES helpers. The helpers are where everything goes sideways. First helper, we have to generate a key from that password. Second one is we need a way to encrypt more than 16 bytes. The last one is we need a way to make sure that people didn't modify the data in transit. This is the most common code I see on the net. This is totally wrong. If you see anybody ever doing a copy of bytes into a key, your AES is totally broken. This is so easy to this is painfully easy to crack because it truncates long passwords, and it uses that's the percentage of the AES 128 key space. I couldn't write down for the AES 256 key space. The number of zeros got absurd. This has no keys in it because people type only a handful of passwords. If you're doing this, stop it. What do you use? PBKDF2, which is what our encryptor uses, or the others. Second thing, if you will see this thing called an initialization vector. Remember I told you that you can't encrypt but 16 bytes. How do you do it? Well, I could just encrypt 16 bytes at a time. That is totally broken. If I just take every 16 bytes and encrypt it, let me show you what that looks like. I take this bitmap. That is encrypted with AES. Yeah, don't do that. There's a better way. It's called CBC. There's a lot of ways to do it. There are ways better than CBC, but CBC is the one you're going to use on iOS. It also happens to be the default. So why am I going on about it? Because this is what you're probably using anyway. The last one was called ECB. If you ever see Electronic Codebook or ECB, walk away. But CBC is the default, and it's pretty good. The problem is that it takes this thing called initialization vector. And unfortunately, somebody decided to put in the header comments that was optional. It is not optional. It's totally not optional. It needs to be an unpredictable number. If you pass null, you get a bunch of zeros. A bunch of zeros is not unpredictable. I can guess it every time. So, well, let me go back. So anyway, the point is you need to pick some unpredictable number. You just send it along. It's not a secret, but you do need an IV. Again, our encryptor will do this for you. You don't have to worry about it. Third problem. It's called unauthenticated. Did you know that just because, whoa, go back here, that just because a message is encrypted does not mean it cannot be changed? And in fact, I'll have the code online to show you how this is done. But if Eve, or evil Eve, intercepts that message from Alice to Bob, where she's paying Bob, this is all without passwords. Eve does not need the password. She can modify it to send the money to Eve. This is AES encrypted. AES encryption does not prevent modifications, even with known modifications. This, by the way, is the Python code required to do that change. So if you think it's really hard, that's what it takes. And in fact, if you want to pull down this mod AES Python script, you can see the whole script end to end. I take OpenSSL output and modify it before your eyes. What do? We do a thing called an HVAC. An HVAC is basically an encrypted hash. An encrypted hash means that if you modified it, I'll notice because it won't work. And because it's encrypted, you need to know a secret key in order to get access to it. The HVAC is kind of, it's not that bad, but there's lots and lots of ways to screw it up. Lots of them. I've done several. These are all the ways you could go wrong. Actually, this is a small set of ways you could go wrong. These are the ones I have personally done wrong and had to fix. And I care about this stuff. And I study this stuff. Don't try to do it yourself. Don't build your own AES format. You go, but Rob, you did. Because there was nothing else available. What should you do? You should either use my stuff, frankly. I like it. There's another format called AESCrypt, also very good. However, it's not as good a library, in my opinion. It's more based around being a command line executable and an end user encryption. But it is a good format. There's not much wrong with it. Of course, it's a little bit. Or hire a specialist. Do not try to come up with your own way to do it. And that's it. I'm going to get out of here before they come for me. Encrypt. Your HTTPS, pin and verify your certs. Encrypt your files with protection complete. Use the keychain, salt and stretch. AES. All done.
Thank you. All right, switching gears a little bit. We're going to now hear, now that you all know how to do your encryption, and wasn't that math sexy? Come on. We're going to now hear about why you really have to do this, because it's the law. Let's play.
Right there.
Gotcha.
That's not it. That's not it. You don't have to. Oh, you're good. Okay. Great. Hi, everybody. I'm a lawyer at the Federal Trade Commission, and I focus on data security and privacy security. And we're based in Washington, D.C., but I work out of our office here in San Francisco, so I'm around. I'm happy to come and talk to lots of meetups and different app developer groups about this stuff, and it's great to see so many people here at an event like this. So I'll talk to you informally as a staff attorney. I do a lot of law enforcement, and I do a lot of outreach. And I'm happy to answer questions. But of course, I'm not really speaking officially on behalf of the agency, so just bear that in mind. This is a slide that's fun to start off with. It's a slide of the logos of a bunch of companies we've entered into what we call a consent agreement with after we've alleged that they violated the law regarding their privacy and data security practices. And some of the laws to keep in mind that are at issue in these types of cases are Section 5 of the FTC Act. That's a huge one. If you can just keep this in mind, this is the basic prohibition on unfair or deceptive acts or practices. Deception is a statement that would mislead a reasonable consumer. So this is your users. This is, think about your product from a user's perspective. Don't think, hey, I'm a tech-savvy person, so my users must understand too that if they click on an ad, that advertiser is going to see in the refer header who they are. That kind of thinking has led to the agreements we talked about a minute ago. You want to think about this from your user's perspective and think, what does my user understand their privacy and security to be? And an unfair practice is one that subjects users to a risk of harm or injury, a substantial risk of harm or injury that they can't reasonably avoid, and it's not outweighed by benefits to consumers or competition. So that could be, I'll talk about some cases where we've alleged that in a minute. And just very quickly, just to keep in the back of your mind, if you're doing kids apps or you have actual knowledge that you're collecting information from kids through your app, you need to keep in mind there is a kids privacy law. It has a whole bunch of requirements. We won't focus on it today. I'm happy to come and talk to people about it in more detail. There's a financial privacy law and a credit report law if you're dealing in consumer reports or financial information. So that's the kind of overview of the landscape of what's out there. And I'm just going to talk to you briefly about our agreements and then about privacy and security cases. So if we do enter into an agreement with companies, here are some of the kinds of things that we've required them to do, what we call the remedies. These are usually 20-year agreements, so if you're just starting out, 20 years is an eternity to you. You know, a year ago was an eternity to you. So this is obviously something that's not desirable, to wake up 6 months later and realize, hey, I've got these requirements hanging over me for 20 years. So they can be an injunction against misrepresentations, a comprehensive data or privacy security or privacy program. So both Google and Facebook, for example, are subject to a 20-year requirement under their orders with us to have a comprehensive privacy program that gets audited by an independent third party every other year. And that's just something that then is a tool for us to kind of look under the hood and learn a little more about their privacy practices. We might make other specific requirements. If you collected information like, you know, say like Path collected address book information and we allege they did it deceptively, because we can talk about it in more detail, but they offered a setting where you could choose to invite people to join you through your address book, or you could choose to email or SMS, but it was collecting your address book information regardless of what your choice was. So in a case like that, we might say, okay, now you have to delete all that information that you collected in these circumstances. We might require special disclosures. And then once you're under order for that 20 years, it's, if we find that you violated it, it's $16,000 per violation per day, which can add up really quickly depending on the nature of the violation and how many users you have. So I just went through and kind of highlighted some of the things to keep in mind, some of the things that we've alleged common privacy failures. So it could be something like rolling out a new service or feature that increases sharing without adequate notice or consent, kind of like what was at issue in the Google Buzz case that led to the order with that company. Misrepresenting with whom data is being shared. And this can be an issue. This is something especially for even the best intentioned developers and others to keep in mind. You really need to know everything that your code does. If you want to use a handy library or development kit, you need to make sure you understand exactly what ad networks get information from your app. We've done surveys of kid-directed apps and other apps where we've seen that lots of information was being sent on to third parties, and frankly, in many instances, the developers had no idea it was even being collected by the app because they themselves weren't collecting it, and that is not a good story to have to tell an agency if we're looking at your practices. So the first step obviously is to know what exactly you're collecting. And then also another common area of failure is misrepresentations about tracking and opting out of tracking. We've had a couple of cases where companies offered an opt-out and it didn't work the way a reasonable user would expect. Okay, I'll skip over this. Okay, another type of failure, enforcement data collection, where I mentioned Path. Like, so this company said they gave you a choice about how to invite others to use the network with you, but then collected address book information. They also collected information from kids without authorization. Here it was not a kid-directed app, but they did collect birthday. If you collect birthday, and some of your users are saying, giving you a birthday indicating obviously that they're under 13, you then have, it's one of the ways that you then have actual knowledge. You're collecting information from kids, and you need to be complying. You promise and compete, another couple cases where toolbars that users voluntarily installed were collecting information. They were collecting more information and in more detail than users would reasonably expect. So even if you're getting consumers to agree to a practice, you want to make sure you guys are on the same page, that you've explained what you're doing in terms that a reasonable user would understand. And this last case that I mentioned at the bottom where I say, oh, you know, companies deceived users as to the extent of data collection, akin to the Sears case. Well, Sears is a well-known case among lawyers, and it's something for you to know because Sears really surprised a lot of people. The company had a disclosure in its EULA, its end user licensing agreement, but the disclosure about the nature of its tracking was, you know, seven screens down in a licensing agreement in a small window at the end of a registration process, and that's not an effective disclosure. So if you think you're dotting all your I's and crossing your T's by getting all the detail in there, you really want to think very carefully about that. If something is material and would be important to your users, you want to make sure you disclose it in a clear and conspicuous way. I mentioned already sharing with advertisers. That has been in MySpace and Facebook. Facebook, it was one of 8 counts. In MySpace, that was the main allegation. Privacy settings and opt-outs, they need to function the way that a reasonable user would expect. In Facebook, they had a couple different types of privacy settings. They had your user privacy settings, where you could choose to share information that you posted with, you know, only friends or only me, things of that nature. They had a separate set of settings at that time called your friends app settings, not intuitive to users at all. We alleged, in fact, that it was deceptive for users because users would think, hey, I already said who I want to share my information with. I picked only friends. Why would I have to go to a separate set of settings and reestablish that I don't want my friends' apps to get that data? So again, just kind of emphasizes, think about it from your user's perspective. Don't think about it in your inside, very, you know, sophisticated and knowledgeable about what you do way. In Twitter, that's a data security case. They allowed you to send direct messages, but back in the early days, some of you might remember, they had a couple of instances where somebody, this wasn't just account takeover, this was people taking over administrative control of the site because they had a public-facing login and no rate limit on guessing the administrative passwords. And so we said, you know, if your security is that bad, it's unreasonable. Any promises, this is basically what we're saying, any promises you're making to consumers about having privacy, they're deceptive because you're not taking even reasonable steps to uphold those settings. Couple other examples. Okay, another thing to keep in mind, material retroactive change. If you're going to make a big change, if you've always said, hey, this information is private, and now you want to reterm it or redeem it as public information or publicly available information, you need to clearly disclose that to users and give them some choice about, you know, you can't make it retroactive to information that you collected under other promises. So that was one of our, again, our 8 allegations in Facebook, is that when they rolled out some privacy changes, deemed certain information public, users didn't have an opportunity to avoid that change. And we had an earlier case along those same lines. This was a very recent case against the Brightest Flashlight app. They had a privacy policy and a terms of use. It wasn't complete, and they also started transmitting data back to the app before the users could accept the terms of the app. So they were so again, this is another thing to think about. Even if you're being complete and you're like, yes, it's conspicuous, check. Yes, we've tested it on people and people understand what we're talking about, check. Make sure the sequencing is right so the information's not coming back to your app before the users get through the disclosure and accept the terms. Okay, so now I'll have just a couple minutes to talk about our data security practices. We've had over 50 cases with companies where we allege that they failed to provide reasonable security. And here, let's think again back to what I told you about Section 5. It's going to be something where they were deceptive because they offered a privacy setting and then didn't follow through with reasonable data security practices, or they had a statement like a symbol of a lock, or something like that looked like a promise of security, or a product name that implied security, so deception. Or it could be unfairness. If you're subjecting people to an unreasonable risk of harm they can't avoid. Hopefully these slides can be made available to you because I'm really gonna keep it moving. So Okay. So here are some common mistakes that we've seen in some of our data security cases since our early cases, and this is going back to the 1990s. Storing information longer than needed. We have a really useful paragraph in our data security cases, and like I said, there are 50. Sounds like a lot, but that's 50 paragraphs right there, and it's the among other things paragraph or the failures paragraph, and you never want to see your company written about in one of these paragraphs where we're saying, among other things, the company failed to. So that's what goes into these paragraphs, these kind of practices. So if a hacker gets your information, you're like, but it's not my fault, it's a hacker's fault. Well, you need to have a reasonable basis for having kept the information. So if you only need information until a transaction is authorized, don't have it around 30 days later without a reasonable justification. Some of the password practices are storing or transmitting information like passwords in plain text, obvious one, but happens a lot, surprisingly. Failing to take steps to segment or restrict access to data, so a hacker can get access to something and suddenly, hey, they can jump around and go, get access to all your servers and all your data. Not good. Employee training and oversight, and also reasonable steps to detect or investigate breaches. That's evolved over time. It would now include, in our recent cases against HTC and Trendnet, having an open channel to receive information about the security of your product from security researchers or others, or taking simple steps to reach out and investigate any security issues with software that you rely on. Okay. And more recent cases have shown that these are surprisingly persistent failures. Trendnet was a case a couple months ago that we announced, our first Internet of Things case where, and this was actually one of my cases, security vulnerabilities in the IP cameras and problems with the mobile app would let people actually take over the camera. They could control it, they could see it, sometimes they could talk to the people who they could view on the camera. And these were marketed as security cameras, so there was also obviously a deception issue. And then you can read some of the complaint language in more detail. And here's something that I think would be helpful. This is some of the quote from some of the failures paragraph I mentioned. Some of the things that they failed to do to perform security review and testing. Sometimes companies may have products, devices manufactured abroad, and we see, hey, you're doing all kinds of functionality testing. Where's your security testing? And you need to make sure that you have something to say, that you actually are doing security testing. And reviewing your security architecture, like don't add a feature, like as we laid out in that complaint, the company had added a feature to let you share your camera feed with people, and they hadn't thought through all the security problems that might give rise to. Okay. So there's the marketing statement and why it was false or misleading. Here's the unfairness. We said there were some potential harms, and we kind of laid out what those would be. Probably good for you to understand the way we think about privacy, and that if consumers are subjected to intrusions into their homes and personal activities, we are likely to examine that pretty closely as a potential significant harm. Okay, HTC I've already mentioned. I'm gonna keep moving here. Rock You, a gaming site, failed to maintain reasonable data security, violated COPPA by collecting kids' information without getting parental consent and meeting the other requirements. FrostWire, I think, is another useful case for you guys. That was a P2P app case from a few years back where, hey, this is a file sharing app. Users expect their files to be shared, right? Well, again, it's more nuanced than that. Do they expect that somebody can navigate around and access any of their files? Or are you subjecting them to the risk of sharing more information than they might reasonably expect? And that's what we alleged here. So even if you think, you're an app like, Twitter, and you're like, hey, most of what people do is public, or you're an app like a P2P app, you still want to think, like, have we offered some reasonable user a sense of what our app does, and are we living up to it? Okay, here's some advice I just want you to know about. We're really working hard to reach out to the app developer community. Like I said, folks are happy to come and talk in more detail about any of these specific laws or cases. We have this marketing your mobile app, get it right from the start, that goes through a lot of what I've talked about here today. What are the things that's important for app developers to think about? And we have a mobile app developer start with security piece that goes through in a lot of detail some of the things you need to keep in mind for security. We also have done some of the surveys and reports on Kids App that I mentioned earlier. So with that, I will leave you with my contact information, and I would love to follow up with you at any time if you have questions.
And we're going to have a little bit of time for questions after our next presenter. Domingo is going to go next and tell us a little bit about how you can, now that you're all scared, like you know you're going to get sued by somebody, how you can actually fix some of those things and use a company to do it for you.
Thanks. Hi, everyone. I'm Domingo Guerra, president and co-founder of Appthority. We scan mobile apps to see how they behave, scan everything from static analysis, dynamic analysis, behavioral analysis. Our main focus is helping the enterprise manage apps that come into their environment. So anyone here using a BlackBerry? How about like 5 or 6 years ago, right? That happened in the enterprise. And employees went from having a BlackBerry to using iOS and Android. And then with that, not just bringing their own devices to work, but also bringing their own apps. And that's our main focus. We'll see if we can get that. But we also end up working with developers a lot and helping them see what their apps are doing, because a lot of times developers, even after they build their own apps, they're not sure if the apps are behaving correctly, especially with the amounts of SDKs, ad networks, and other libraries that they end up using in their code. Appthority, we've analyzed about 2.3 million apps. We run static, dynamic, and behavioral analysis and identify the hidden behavior in apps. Again, most of our focus in the enterprise, but I know everyone here is a developer, so we're going to tailor the discussion into the top 5 fails we see from a security perspective. But first, when you hear app insecurity, most people think malware and, as a default, Android. But who's really responsible for the risk we're seeing? Again, surprisingly, malware is less than 0.4% of all the apps out there. Sure, it's growing exponentially, but growing from 10,000 samples to 100,000 samples, it's an exponential growth, but it's 100,000 samples out of millions and millions of app samples out there. So malware, bad people making bad apps, malicious intent, no amount of talks are going to change that. I'm not going to convince anyone's mind to stop writing malware. But hopefully we can get a few more of the good folks that are writing bad apps to improve their code. Again, that's 81% of the apps we've tested. It's not malicious intent. It's good developers making mistakes, using bad tools, or just being lazy. Rob pointed out earlier some of the tools that are available. But less than 20% of the apps we've analyzed would pass an enterprise-grade security test. And again, a lot of developers say, I'm not building enterprise apps. But your app sits on a device that some government official is going to take to work, some executive is going to take to work as well. There's confidential data on those devices. Security really is about the weakest link. And sometimes that might be our applications on folks' devices. So we did a study. We focused on the top 500 iOS and Android apps, free and paid, and said, OK, what are the best developers out there doing? Well, from an enterprise perspective, a lot of times it's concerning when a lot of apps that don't need your calendar are removing your calendar, or your address book, or location tracking. And then another thing from an enterprise perspective that's concerning is the amount and the increase in in-app purchasing. Why? Because they're reimbursing their employee cell phone bills, and sometimes you can get carrier billing for in-app purchases. And sometimes it's not clear that the app can have in-app purchasing, and people end up spending a lot of money because their kids bought virtual goldfish or something. But then we said, OK, what about iOS versus Android? We expected Android to be way more insecure because of what we hear from a malware perspective. But actually, iOS developers are requesting more permissions in Android. And this is sometimes for the same app, side by side. So we would see EmojiCon app developed for Android with no permission request, no data request, and then that same app on iOS requesting all kinds of stuff. Why? Ad networks in general pay more money for iOS user data because iOS users are seen as a premium. 20% of iOS apps, of the top apps, collecting calendar, even though they had nothing to do with the calendar function, or few of them did. Almost 40% collecting the address book. Again, not all of them were social networking or things that would require the address book. Sometimes the developers didn't even know this was going on because that was through their SDKs they were using for their ad networks. Identify user, this is actually going to increase this quarter because now iOS users found different ways to track users without the UDID. This was right after Apple had said developers were not allowed to use a UDID for location tracking, sorry, for user tracking. But now you can have a specific identification within app, not across apps. The next thing we found interesting from a developer perspective is how fragmented the space is. From the top 100 free and the top 100 paid iOS and the top 100 free and paid Android apps, there's anywhere between 79% and 88% fragmentation, meaning the top 100 apps come from 88 different developers. It's hard to find, as a user, a trusted source of apps of saying, OK, I'll only download apps from developer A or developer B, because really, every app you download pretty much is made from a different developer. What that presents also is an opportunity for developers to distinguish themselves as being, hey, we're better with privacy, we're better with security. Start building a brand, not just on functionality, but also on how we handle our users' data. So finally, the last one from an intro is, what are some of the impacts of not following security and privacy guidelines? Well, first of all, it hurts your users. It's hurting their personal data, but also their corporate data. Again, because of BYOD or bring your own device, very few folks use their phone or tablet for just entertainment anymore. A lot of times they're using it for work. So even if your app is not work specific, it's going to be in an enterprise environment. It's going to be in a government environment. So just keep that in mind. It hurts. So not following security and privacy hurts your brand. We're going to call out a few folks, a few popular apps that had some mistakes. You don't want to be on that list. Normally, they get a lot of press, and it's not the good press you want to get. Second, it can have impact financially as well. You can get banned from app stores, and we've seen that happen. You can be banned from enterprise environments. And if a big company with 20,000, 30,000, 80,000 employees bans your app from use, that's a lot of potential important downloads that you're losing there as well. And then finally, as we just heard earlier, government is starting to step in. Apps were kind of in this gray zone where they weren't really affected by internet laws and privacy laws, but now they definitely do. The fines can get pretty extensive if they're especially a fine per download. So even a $1,000 or $2,000 fine per download could be millions of dollars before long. So what are the top 5 fails we see? Using risky SDKs or libraries. Permission bypassing, so too many permissions, too little permissions, or going around permissions. Dirty laundry, so things we leave about ourselves as developers in our code and in our apps. Improper handling of private data, and bad cryptology. And I won't go into too much technical detail as Rob did, but I'm just going to show some of the examples in the field we've seen. So fail number 1, ad network risk. Know your ad network, know your libraries, know your third-party code. It's easy. You import someone's code, and then your app has more functionality. But a lot of times, it can put you at risk. In this case, it's a popular ad network that adds a lot of permissions and behaviors, but more importantly, puts you out of compliance in terms of COPPA, which is the Children's Online Privacy Protection Act. And also, some of the ad networks we've seen are pretty aggressive in terms of advertising. So it can be pretty intrusive for your users. But let's give an example of what this ad network collects that the developer didn't even know. So yeah, you read that? OK, we'll make that easier. But taking anything from APIs, IMEI numbers, timestamps, but more importantly, age of the user, phone number, zip code, location, et cetera. A lot of times, the developer didn't know they were doing this, so it's not on their privacy policy. And now you're out of compliance. So know your ad network is one. Few steps into evaluating them is, one, what do other developers say about them? Does the ad network have a privacy policy? Read that, because your users probably won't get a chance to read it. They won't know what ad networks are on your app, but you will. And it's ultimately your responsibility. Find out what kind of data the ad networks collect. See if any of that data is considered private, especially if you're working with kids. Some of that data is definitely private by definition. If you're working in certain geographies, in Europe, for example, there's very strict privacy laws. So if you have users in Europe, you want to be aware of what those laws might be and make sure your app is not collecting the data. And if you don't know how to evaluate a NAT network, consider using third-party tools. There's a lot of them out there. A lot of them are even free. So do some research on that as well. Fail number 2, permission abuse or bypassing the permission consent. We see mostly on Android, where you have to ask all the permissions up front, but also on iOS, developers that request way more permissions that they're going to need. A lot of times they're saying, well, I'll do this. I'll collect a lot of permissions up front, even though I don't need them. And if the future, if I ever need them, I'll already have the permission. But meanwhile, you're making some compromises in terms of privacy and security that you don't have to make. The other aspect, so the 3 main fails are, you didn't ask enough permissions, you still need to do the behavior, and I'll show how some apps are going around the permission model to still collect the data they want. You ask too many permissions, or the confused deputy, which is you are being victim from another app abusing your permissions, or you're abusing another app's permissions. I'll go into some examples there. But the first, the application didn't ask enough permissions, it still needs an action, and goes around it. So in this case, eTrade, both iOS and Android, doesn't ask permission for location because it's not using your GPS. But there's ways to collect the user's location with GeoIP or IP address or even Wi-Fi location tracking that don't invoke that permission. So don't think you're being clever by collecting information without asking the user for permission. That actually puts you out of compliance, and you might get targeted by our earlier speaker. 2, requesting too many permissions. The opposite of the first one is saying, well, hell, if I get the users to agree to everything, then I'm safe. The problem is that brings a lot of other security issues as well. If your app has access to the camera, to making calls, to do everything, now your app can be, especially on Android, can become a target because now other apps that need those permissions but don't have that can try to go through your app to do that, and I'll show that in the 3rd example. In theory, this wouldn't happen, but with auto update, that's kind of enhancing or encouraging users or developers to take advantage of this because they say, OK, I'll get it once, and then I don't need to ask in future updates. But a few examples. There was a Grand Theft Auto walkthrough with over 10,000 downloads that requested 50 permissions on Android. That one was pulled from the market, but this one's still on there. So it's a joke screen with 45 permissions, everything from install and delete packages to mount format system files, get all accounts for a wallpaper, right? So careful out there. The last one doesn't happen very often. It's mostly an academic one, but it's a concern on Android specifically. If you have a lot of permissions and your user knows that you can send SMS and you have that permission, an app that doesn't have that permission could try to then send intent into your app if your app is not well protected, and then you end up sending those texts. Now, if those texts happen to be a paid SMS number, now your app is enabling SMS fraud. The user's not going to care that another bad app did it. The user's going to care that your app enabled it. So it's just one of the things to look for, especially for developers that are also developing on Android. Fail number 3, dirty laundry. A lot of times we have notes when we're building apps. We have design review meetings. We might be sharing comments. We might be having debug information in our apps. It's important to delete all that before we publish the app. Sometimes you have information that might help an attacker break into your app, and it's right in the app. In this case, I blacked out Casey's name, but Casey works for Pandora, and we know that because we saw his file structure inside the Pandora app. And we saw some design review notes between him and another developer called Chris, arguing back and forth about some functionality, leaving notes for each other. Well, don't leave your dirty laundry in your app when you put it into a public app store, because folks like us can see that. And we didn't do anything bad with it, but malicious intent, malicious folks could use that information to know your file directory as well, know information about your app. Fail number 4, improper handling of private data. Anyone use Tinder? Anyone know what it is? So Tinder, for those that don't know, you receive a picture of someone, their age, and their general location around you. You just say if they're hot or not, and if you say they're hot and they say you're hot, you're put in contact. Except it's not built very securely, and we'll go in the show why. But they use Facebook and give you just the persons on the screen, all you see is a person's first name, their age, and their general vicinity, a few miles away from you. But they're collecting information way more granular than that and sharing that to the device. Even though it's not made available to the user, it's still on the user's device. So poor Amanda here, we blacked out her screen, but Amanda's 30, on our screen we see Amanda 35 and a few miles away. But Tinder app actually sent us her full birth date, her full ID for Facebook, first name, last name, etc., and her full location. Very granular location here. And again, with the amount of potential stalkers and security around there, we made this report public. But it was very easy for anyone using Tinder to say, oh, that's Amanda, and that's her full Facebook. And now I know exactly where she is the last time she logged in, or if she's online right now, I know exactly where she is. She could be at the Starbucks down the street. Pretty creepy. So we made this public. Tinder made some changes and said, OK, they crossed out the position. They no longer give you the exact GPS coordinates. They no longer give the exact Facebook profile. But then they were still giving the exact distance away. So if I know you're exactly 3.6830 miles away from me, how quickly can we find out exactly where they are, right? The shortest path, right? So I say, OK, I'm going to move 1 block this way. Did it get closer or farther? OK, got farther. Another block that way, closer. And pretty quick, you can write a script to, again, know their exact location. So they since finally fixed that. But sometimes we don't think about it. We just say, oh, OK, I need a user's location for my application to work. Let's just give those coordinates. You don't need to know to the decimal point exactly where someone is. You can, and if you do have that, it's easy to obfuscate or obscure that to other users that might abuse that. So just say, round it up. They're within 2 miles or within 1 mile. You don't need to know 1.056 miles. The bad news is it wasn't just Tinder. This is very common from all the dating apps. They're all doing that exact distance, sometimes exact IDs and everything. So if you're users of these apps, be mindful. If you're building these apps, be more responsible. Because, again, it's not just hackers trying to steal information. This is sometimes people's privacy and people's livelihood at stake. Again, we all have friends that could be affected by this. But anyway, fail number 5. Using bad, or even worse, no cryptography. So Rob talked about it. There's a lot of tools out there. Even just using HTTPS is free. It's easy. But so many folks are not using it. In this case, Postogram app, you take a picture. You can print a postcard and mail it directly to your family. Except they don't tell you that when you take a picture, it's saving it to a public cloud without any kind of shading the usernames. So then folks can just go into that cloud and start browsing everyone's pictures. So all the pictures of your kids or all your pictures that you have with your family and travel or whatever, they're out there and folks are just looking at them. And they're sent without encryption over the wire as well. So even if the place was hidden, a hidden server, it's so easy to find it. And a little bit more on behavior number 5 is some more popular apps. Not encrypting traffic in motion. So sign easy, you can sign a document on your iPhone or iPad and send it out. A lot of folks use it to sign confidential documents. They're encrypting the document transfer. They're encrypting the document storage, but they forgot to encrypt the password for the user's account. So again, don't do that. And then not encrypting data at rest. The Starbucks app saves your username and password in clear text, straight on your iPhone. So again, people say, well, what's the big deal? Someone can order some coffee in my name or something. Well, some folks have it to auto-reload, so you could order a lot of coffees. Or some folks use their same password for their coffee as they do for their email or for their bank account, so it could have consequences there as well. So don't compromise functionality and saying, well, we just want to make it easier on the users to not have to log in a lot. That was their excuse, by the way. There's simple tools and free tools with iOS that you can do that using Keychain, that you still have the user ease of use without compromising security. So it's not really an excuse there. So again, the 3 main things we see is not using SSL. It's free. Use it. Storing passwords or transferring passwords in plain text. And then not expiring auth tokens. A lot of folks are using Facebook to single sign on all your apps. It makes it easy. It gives you a built-in social network. But no, the Facebook security might not be as strong. so maybe it's not always good. Until recently, Facebook auth token was set to never expire. So you log in once and you never have to log in again. They've changed that now, I think, to a few months. But if someone compromises their Facebook account and you use Facebook to log into your app, so that now they can log into your app and about 60% of the apps on your phone. So just in conclusion, the reality is all of these mistakes are avoidable. You don't want to be losing downloads, losing trust of your users, or worse, getting fines. And it's not very difficult to do. So it's easy. It's on us to not just worry about user interface and user functionality and user experience, but also user security. So hope this helps. Happy to answer any questions. And my co-panelists will be out here soon. Thank you.
All right. Get this one on here. Un momento. We live? All right. So, any questions out there? Raise your hand, the microphone will come out to you. All right.
Hello, here we go. Question for Laura Berger. App developers, analytics is very important in seeing what people are doing and so forth. Are there examples that you can cite of applications or others that have been cited for not adhering to proper privacy policies and collection of that sort of data, and especially with a third-party analytics provider? And how do you find out what the privacy policies are of some of these third-party providers?
Okay, so so a two-part question there. Are there cases where we've looked at sharing? I mean, I don't know that sharing with an ad network or an analytics company, again, you said third party, it's not really to us when we're looking for unfairness or deception, it's not any different than sharing with anybody else. So, you know, yes, we happen to have cases where, like, you know, I mentioned Facebook. We also had a case, Chitika, which offered you an opt-out of sharing with advertisers that didn't work the way that it was supposed to. We've had cases that very specifically cited to the advertising context, but we've had lots and lots of cases where, you know, yes, you know, there was deception about the sharing with the third party. You mentioned how do you find out what the third party's practices are? Can you explain? Are you saying that you are making representations about what the third party network will do and you're concerned that they're not accurate? Or?
Well, in a former life, I've been in a situation where we were collecting some analytics, but and using a third-party tool, but it was very difficult to find out from that third party enough information to inform our users about the retention of their data, for example.
Right, right. I mean, we have had lots of cases where you know, we've made pretty clear that if you have somebody that's your service provider, like an analytics company that's just supposed to come back to you with information, and you tell your users that, you say, hey, we you know, may share your information to get, you know, information to improve our website. So we may have service providers for that. You are responsible if you're not taking reasonable steps to oversee what they're doing, and, you know, you've given your users some assurance. So, you know, I don't know the magic. Others might have more insight about how you get them to, you know, be upfront with you, or some of the tools to kind of check up on them.
So I mean, there's several tools that folks use. Again, I don't do a Google search for privacy and then ad network or privacy that. There's a lot of organizations that do that as a nonprofit. Sure. I can't promote one over the other as a player in the space, but there's several free tools that rank the different ad networks, the different, like, analytics companies by how they collect data and how they manage that data.
But if they're not coming forward, I mean, if you're having to dig, you have the wrong partner. Because you're taking risk.
That's kind of true. Oh.
Hello. I have a popular sports game. Sorry, this is for Laura. I have a popular sports game on the iPhone with millions of players. It's not for adults. It's not for children. We're happy for everyone to play it. Right. And so I'm unclear about how COPA affects us. We never ask an age or a date of birth.
Yeah.
Sometimes people email customer services and they really sound like they're a little kid.
Right. Right.
What does that mean?
Yeah. So I don't. So, you know, it applies to kid-directed apps, which you are not, the kids' privacy law, COPPA, or it applies to general audience apps if you have actual knowledge. And actual knowledge can be derived in a number of ways. You're not like, if your site is like a conversation site where users are talking to each other, trading sports statistics, we wouldn't expect you to read all the traffic between users on your site and monitor it to look for evidence and investigate in that way. But if somebody brings it to your attention, like a parent, a concerned parent writes to you and say, hey, you know, what are you doing, you know, sending my kid, you know, all these offers to, you know, whatever, you know, what are you doing with all this information about and my kid's address and stuff like that, then you have actual knowledge. So it could also be things like if you see a picture of the user and the user is clearly like standing with their third grade class at school, or, you know, in a context by a locker where you know they're a kid, something like that. So, but trying to infer it from, you know, their grammar or something like that is a little shakier.
Can I have one brief follow-up? So if that happens and a parent contacts us and says, what is this app doing?
Yeah.
Can my remedy be, if you delete the app, it won't do it anymore and it will delete that information it has?
Yeah, yes, you can. You can immediately delete that kid's information. And then, you know, work with the parent. You should provide them with a copy of your privacy policy. And if they have further concerns about what may have already happened to the kid's information downstream, you should work with them, you know, just to serve your users well.
Okay, thank you very much.
Yeah. Mm-hmm.
So also, just to clarify, it's not just deleting the app from the device, it's deleting the data that you've collected
that you collected from the kid.
I think this question's more for Rob. Whenever you submit an app to the App Store, there's a checkbox that says, does this app include security? What is that for? When do you have to check it?
Lawyers have, okay. You have to talk to an expert lawyer, because I once had an opinion on this. And Edna Conway, who was an awesome lawyer and swears like a sailor, ripped me a new hole explaining why I don't get to have an opinion. Honestly, my understanding used to be it's provided by the OS, and you didn't export it, and therefore the Apple exported it. I have been told that that is not necessarily true anymore in the last 5 years or so. I mean, in several years. And that it has changed. There is a site, BIS. The government provides a site, and they will walk you through it, what you have to do. I wish I had the answer to. Typically, I would go ahead. I mean, you can check it and say what you do. Because HTTPS is covered by those rules. I mean, everything is covered by those rules. But it's unclear to me. And I care about this stuff, and it's unclear. I wish I could tell you the answer.
So consult your lawyer.
Consult your lawyer. I hate that, but that's all I got.
Hi, I was at another meetup where game developers were talking about, and it surprised me, including dozens of other third-party SDKs in their games. Given that a lot of these SDKs are closed source, and I don't have the capability of auditing them, what are the risks, or should I even ever consider including a closed source SDK in my apps?
Yeah, I mean, we see sometimes 20, 30 different ad networks in a single app, multiple crash reporting tools and user authentication tools. And you don't have to reinvent the wheel when you write an app. There are a lot of tools out there. Just not all tools are created equal. The tools need to be forthcoming with what data collection they have. Include that information in your EULA. So it's not just what you collect, but overall what the app has access to. And then also have that communication with those shops. I mean, a lot of them are pretty serious businesses too, so they will lose customers if they're not open with it. Don't just go for maybe the cheapest one or the obscure ones, I guess.
I have a question specifically about kids protection. COPPA usually works with parental consent. What should we do if the parents are the problem? So last week we had a case with an app that is a quiz app, educational for kids, where we don't collect any data, but we allow users to give feedback if something is not working. One user wrote, I don't like it that my mom is so violent. And so we can't, so all we have is an email address now. So in this case, what we did is we analyzed the email address, found that it's from a charter school. We alerted the authorities in the charter school. But in general, if the parent is a problem, what can we do?
Yeah, and we have, and I would have to look back at the rule or commentary to see if this is memorialized anywhere, but we have read into COPPA an accommodation for steps you need to take to immediately protect the health or well-being of a child. So if you got a call to like a suicide hotline, or it would have to be an online site or service, but if you got an email indicating that somebody was in imminent physical danger, of course you can act on that. So.
The specific question is what, in this case we found authorities we could alert, which was the school that we found. But if we say we had only the parent's email address and the parents are the ones that are accused by the child, who should be alerted? I don't think we can just let it go, or what should we do?
Right. I mean, that's an area of that's not an area that COPPA really addresses. Okay. That's not an area of COPPA compliance. Seems like a really important question, but I don't know what information you had to go on in this particular case. But I mean, COPPA has a number of exceptions and accommodations for situations like that, so you don't have a COPPA problem there.
Okay.
Yeah.
My question is for Laura. About the second slide you put up was a who's who of Silicon Valley companies. Why wouldn't I want to be on that list?
Okay, yeah.
It seems like I haven't ever heard of a FTC putting a company out of business or leveling a fine, and it looked like the remedies you required were behaving like an ethical software company that is having privacy policy training and occasional outside audits.
Right. So you want a general comment on our remedies?
Well, so why should I care?
Yeah,
basically.
So I mean, different companies have said different things. If I could wave my magic wand and change our remedies so that we had, that first instance fine authority, I would do it, and the agency has asked Congress for that. We have it under COPPA, so the Kids Privacy Law, the Fair Credit Reporting Act for Consumer Reports, and some other rules. But under the general deception, you're right, you're absolutely right, we can't get fines in the first instance. So, companies, it's funny what people say, and I think that's very candid of you, but during the investigation process, which is really lengthy and requires you to hire a lawyer and will take a lot of time and resources, and you may be doing depositions where you have people who are your top programmers sitting in a conference room with somebody like me answering questions all day, it is a drain on your resources to even go through the process, and we take it very seriously. We don't open investigations lightly. But at the same time, to be subject to the threat of the $16,000 per violation per day penalties for 20 years, it's not nothing. Like, nobody likes to have that kind of, you're under that order and you've got that hanging over you, and none of your competitors has exactly the same thing hanging over them. And so it's not a good situation to be in. It's not I would like to have more remedies to impose in my cases too, but we still think we take it very seriously.
If I could add, I was at a company that was under an FTC consent order, and believe me, fines or no fines, you do not want to be under that sort of process.
This is a question for Rob. It's a question about securing servers. If you're setting up a server where you know that your app is the only thing that's supposed to be talking to it, you talked about certificate pinning, but you didn't mention SSL client certificates. Do you think that's appropriate?
I don't think
or
there is not much purpose, in my opinion, to client certs for apps. There are good reasons for client certs, but not for apps, because I know I was just talking about this yesterday with somebody. You cannot authenticate devices. You can't authenticate iPhones, because everything that is on the iPhone can be copied off of it. All you have to do is jailbreak it, and then I can put it on other things. And if you bake that certificate into your app bundle, it means everybody has it. I guarantee you it's gone. You can only authenticate users. That means that you need a different client cert for every user. It can't be baked into your app. And there are cases where that's useful. If you have an environment where, especially enterprise environments, sometimes that's actually useful. Most of the time, though, client certificates don't exist for security reasons. They exist for ease of use. because they simplify two-factor authentication. Usually the point is I issue you one, and that ties your password to also this phone. And I'm betting that it won't be stolen off of this phone. But no, most of the time I find that client certs are not worth the trouble for the vast majority of problems.
Yeah, this question's for Laura, actually. I was wondering, how mature is the legal industry in terms of law firms, and how many is it like established journals, or in your experience in helping companies deal with these issues?
Wait, I'm sorry, I missed the first part of your question.
How mature is the legal industry in terms of like lawyers you see out in the field practicing this stuff?
That's interesting. Yeah, in the specific, I see a lot of, there's a really new business model of privacy consultant. Like last 5 years, and so you're not working with a law firm, you're working with an independent consultant who maybe can have the time to come and sit in your room, your big conference room, or your big room where all your developers are sitting, and kind of get to know what you're doing and give you advice. And I know that's worked really well for some smaller entities. But I think the bar, the kind of corporate bar, is pretty well developed and pretty mature. I know I see a lot of, it's a small bar, I do see a lot of the same opposing counsel over and over again, but I think the privacy consultant business has been a really positive thing.
All right, any other questions out there?